presentation here. And so here's the homepage for my website, and it's kelvinwairimu.com. And this is about me. I'm an aspiring robotics engineer. I'm driven by the passion for designing and building intelligent systems that bridge the gap between humans and technology. And there's some slight nutshell about myself and my inspirations and some of the things that I'm looking forward to. And when I look at the portfolio, assigned was to design and complete robotics and embedded system solutions that apply to real world situations and challenges, implement a simple microprocessor, demonstrate the embedded systems, and by design skills and apply knowledge of transducers and design and analyze real-time embedded system solutions, and also to implement and evaluate algorithms and methods enabling autonomy in a mobile robot. And all this is highlighted, is very well highlighted also. When we look at objective one was to design and complete robotics and embedded systems so that apply to real world situations and challenges. And so some of the real world situations here is how you open your gate and also in electric cars. And this objective does meet its requirements by showing how applicable it is to real world situations, to the practical integrations of motor controls and technologies. So here's the GitHub account for here's the GitHub link for my codes for that, and the YouTube link, and also Tinkercad, and also here's the schematic image of it and an image of the two motors running concurrently, and also here's a slight video showing how it's running. So you can control even the directions using when you play, even the speed. All these are very well put in place. And so when I move to objective two, it's about to implement a simple microprocessor using digital logic design. And a common applicability of this technology is on traffic lights as depicted below. So this project, the microprocessor ability to manage timing and sequencing is applied to a traffic light system. And so by utilizing a timer, the microprocessor is programmed to control the duration each light remains active, ensuring orderly and predictable traffic flow. So this highlights the core principle of digital logic design. And so here's the timer I'm using is a 555 timer here. And here's the video showing that. And also here's the schematic flow of it. And also another one is I use this as an alternative design that still works the same, pretty much the same thing. And when I play, you can see the LEDs are blinking. Perfect. And when we move to objective three, it talks about to demonstrate how embedded system design skills, including but not limited to microcontroller selection, schematic design, printed circuit board, layout design for electromagnetic compatibility design for manufacturing. And so in these, I looked at I used the ultrasonic motor controls to detect distances while parking and alerts the drivers. So by integrating these ultrasonic sensors for distance detection and motor controls for real-time feedback. So this project does demonstrate how embedded systems can enhance driver safety. And so this is the image, and that's the schematic. And when I play, you can see the more closer you're towards the object, the sensor just brightens up. On the other hand, we also did look at objective four is to apply knowledge of transducers, actuators, and simultaneous hardware and software development in the design of embedded systems. So analysis of LED matrices to create dynamic light patterns or animations can be observed below, and source code is attached. So I have it set at 100 microseconds for the LEDs to blink systematically from left to right. So the command given is very systematic and helps to manipulate the blinking periods. And so as you can see here, this is a good clip showing. I have it set at 100 microseconds on the source code. You can see this is a schematic flow. This is the second schematic for this other example too that works. The same modality still applies on these. And when we move to objective 5, is to design and analyze real-time embedded systems, including advanced digital logic design, signal processing, and high-speed digital systems. And so in this case, the objective 5 meets the objective by designing and analyzing real-time embedded systems through the practical application of advanced digital logic using simple circuits. The breadboard setup and digital logic schematic demonstrates how fundamental logic gates are. And so this is a good example of how the design went through. Hands-on circuits, this is a good example of that. And also, as you can see, we had gone over this before. And the final objective is on objective 6, is to implement and evaluate algorithms and methods enabling autonomy in mobile robots. So the below diagram shows how to connect the L298 IC control to motor controls. And objective 6 does meet the objective of implementing and evaluating algorithms that enable autonomy in mobile robots. Still the same modality apply here, does apply here. This is the example that we used. And here's the GitHub account link towards the code, source code for it. That's the schematic part of it. All right, that should be all from me here. Unless you have any questions, can you feel free to reach out back to me. Thank you.